In the state of Mississippi, there are three regulatory agencies that have some say in that process. It's Department of Ag, the Department of Health, and the Mississippi Department of Marine Resources. Our role in seafood safety specifically is we have the Seafood Technology Bureau that's responsible for that. And in response to the BP oil spill, we've done several additional things than what we normally do. We've done this for decades, keeping seafood safe for the state of Mississippi. We do dockside evaluations. That means where our inspectors go down to the docks where the product is being landed and does evaluations of that product there. We also do the actual water quality. We do that in conjunction with the DEQ. We also do sampling of the product while it's out in the water. We take tissue samples of shrimp, crab, fish, and oysters.
The protocols and the standards that were used for sampling and for analysis of the seafood in response to the Deepwater Horizon were adopted at the federal level and at the state level. So there was consistency in how the sampling was done as well as how the analyses were done. All those samples come back to this lab. We have a National Seafood Inspection Laboratory that's part of this facility. So the sample processing is done here, the sensory analysis is done here, and then samples are sent to the Northwest Fisheries Science Center for chemical analysis.
So when we receive seafood samples at the lab in Pascagoula, Mississippi, they're processed and prepared for sensory testing, which is a well-developed test to detect odors from petroleum. If the sample passes that test, then the sample is analyzed by an analytical chemical test, which looks at specific compounds present in oil called polycyclic aromatic hydrocarbons. And the FDA, based on a lot of science, has determined that those are the compounds of concern from human health. So during this spill, those samples were sent to our Seattle National Marine Fisheries Service lab, where they were extracted and then put on a very sensitive instrument that separates the compounds into their individual compounds and then detects them in a very accurate and very specific way.
The types of species that we take, so far today, we have 18 different representative species of fish that have been taken. And those are representative samples from the top waters, the pelagic type fish, and that would be things like mackerels and cobia and those types of, and they are offshore species of fish, and they're inshore species of fish. And we got the mesic fish, and those things include things like the drums, the menhaden, and then we got our bottom dwellers, which are things like flounders and catfish and ground mullet, speckled trout. So it runs the whole gamut. We have three different species of shark that we've taken. So we're very confident that we're selecting the species that represent, as far as seafood safety, the things that the public would come in contact with, and those data are available on our website. And like I'll say again, they have all come back non-detect or well below the NOAA protocol. So those hundreds or thousands of times, in some instances, below those protocol levels.
Fish, shrimp, and clams, and bivalves, as they're called, all handle pHs in a different way. These compounds have been in our environment for a long time, and so these animals have adapted to dealing with their presence. So in the case of shrimp and fish, they have the ability, when these compounds are taken up, to what's called metabolize them, turn them into compounds that can be more easily processed and then excreted, gotten rid of by shrimp and fish. And what that means is that the pHs that were taken up don't have the ability to get to the edible tissue, the muscle tissue. The public needs to recognize about difference between chemicals. They're not all the same, and in the case of pHs, they can be metabolized and excreted. Other compounds, they cannot.
There's new research, the dispersant research that was done for this oil spill. That was new research. That was something that we didn't have a lot of science behind. So there was, very, very quick turnaround time trying to get that research in place, get the result, look at the impacts of the dispersants on seafood safety. So that was, something we learned with this spill that will apply to the next spill.
During the spill, the American public and people in the Gulf became very concerned about the amount of dispersants that had been used and whether or not those dispersants posed a health risk to people consuming seafood. So in response to that, FDA and NOAA worked diligently during the spill to develop a new method to be able to detect a compound present in dispersants called DOS, dioctyl sodium sulfosuccinate, big word, but it's just a compound in DOS that we felt would be a good marker of the presence of dispersant if it was present. But what we did know from the literature and the findings and what we know about these chemicals is that the potential for any accumulation of the dispersant compounds in seafood was very low.
The science, stands behind the results. And again, I would say that the seafood in the Gulf of Mexico is safe. There's nothing wrong with what's reaching the market right now. It's being checked at many different levels, and it's never failed.